Dear student, I am Sarang Vivek Tare, working as an assistant professor in Sinhagad Institute. My total teaching experience is 10 years and I have completed my masters in heat power. Today we are going to see the heat exchanger topic, and today we will focus on the LMTD method. So let's start. So you may be aware, heat exchanger is a device or equipment which is used to exchange the heat from one fluid to another fluid with maximum rate, minimum investment and running cost. So we will see today what is meant by LMTD. LMTD is known as logarithmic mean temperature difference. First we will see the definition. It is the temperature difference which would give the same rate of heat transfer as actually occurs under variable conditions of temperature difference. I know by reading the definition you will not get what is meant by LMTD. So without wasting the time, we will see the expression related with the LMTD, and there are two types as we already covered in the last session, uh, that parallel flow and counter flow. So we will see LMTD for the parallel flow today. So we need some assumptions for this LMTD method. The first assumption you can see here, the first one is the overall heat transfer coefficient, generally it is denoted by capital U, is constant. This is the first assumption we have to consider. Second is steady flow rate. We already discussed what is meant by steady process, so I will not waste our time to discuss on the same. Third one is specific heat and mass flow rate is constant. Fourth one is no heat loss to the surrounding. Fifth one is no change in phase of both of fluid during the heat transfer. As we know, because of heat transfer there may be changes of phases of the fluid, so we will consider there is no any change of phase of both fluid during the heat transfer. And last one is change in kinetic and potential energies are negligible. So this is again very important assumption we have to consider, and we will start the LMTD for the parallel flow heat exchanger.